All right, hello, and welcome to your first video lesson of the semester. We are in Eureka, Module 1, Lesson 1. Here we go. So, this module deals with polynomials. And as we deal with learning about operations involving polynomials and doing all this different math and algebra regarding them, let's first look at the underlying pieces of polynomials. So we'll get a chance, especially in pre-AP algebra, to look at kind of what's going on in the structure of these polynomials. And we're going to do that first by looking at first, second, and third differences. We're actually going to be able to find out a polynomial that matches a relationship. Pretty interesting stuff. So here we go. First, you have a table of values here, and the first thing that's up there is it's just a number. We're starting with this number, all right? And then what we have next here, this 5.76, is the number squared, right? So that's the square of it. This next number that we come across, this 5.8, is actually our first difference. So what 5.8 is, so this 5.8 here is actually going to be 11.56 minus 5.76, right? And that's going to give us this first difference. If I can spell correctly. All right. So this next number, 2, is what we're going to call our second difference. And what that is that's just 7.8 minus 5.8, right? So that's where that comes from. So we're going to take a number and subtract it, right? So let's look at it. 2.4 squared is 5.76. 3.4 squared is 11.56. We find the first difference by subtracting the 3.4 squared, subtracting the 2.4 squared from the 3.4 squared, and then we keep going on down. Have a look at that. It'll make sense you keep looking at it, all right? So our next question that we get is, assuming that the pattern continues, all right, you can find the value of 7.4 squared. And let's figure out how to use the pattern to find that. All right, so check it out. If we were to continue this out, right, so that would give us 7.4 here, right? And we want to know what number goes right here, right? What is that supposed to be if that gets carried out? Well, right now we have, if we look at this piece, right? I'm going to write that down here. 11.8. We got a 2 here, right? We see this pattern of 2's on the bottom, right? So we know then that there must be a 2 here. Well, if I want to get the next number, I just need to add 2, right? Because you can see this, this first difference, right? Each one of these is increasing by 2. 5.8 plus 2 is 7.8. 7.8 plus 2 is 9.8. And so on. So I can add 2 to find out that this one is going to be 13.8. Okay. All right, so where did this 11.8 come from, right? Well, 11.8 was 40.96 minus 29.16. So how do we get then the number that is supposed to be above the 13.8? In other words, what goes here where our question mark goes? Right? So if I was subtracting to get the 11.8 or the 13.8, then I could add to get the next number. So this number right here is going to be 40.96 plus 13.8, which is going to be 54.76. And it's asking us in the next question, how would you label each row of numbers in the table? Well, that answer is actually sitting right there. So let's move right on. All right, so this discussion piece is just there for us to find first and second differences in terms of some variable quantities. Instead of using numbers now, we are going to actually represent these with polynomial expressions. So let's get that work done right now. So let's ask, what is the sequence of first differences for the linear polynomial given by ax plus b, where a and b are constant coefficients? Whoa! Right? Oh, let's work through it. It's not as bad as it sounds. All right, so our sequence that we're going to generate is going to be created by allowing x to have different numeric values. Right? So essentially, our first term will have x equal to 0, right? So that means that our first term is going to then be, well, just b, right? If x is 0, yeah? And then our second term, we're going to let x equal 1. And so that would be a plus b. And then following the pattern, our third term is going to be 2a plus b. And you see the pattern form there, right? It's a sequence which is a pattern. And we'll have 3a plus b. All right, let's look at the first difference, right? So our first difference, what we're going to do is we're going to take, for our first difference, we're running out of room, so I'm going to abbreviate difference as diff. We're going to do a plus b minus b, right? So a plus b minus b. We're taking this one and we're subtracting. Okay? So what is that going to be? It'll be a. How about our first difference of our third and second term? That's going to be 2a plus b minus a plus b, which again turns out to be a. What do you think the next difference is going to be? It's going to be a form of pattern. So the sequence of first differences is going to be a, A, right? And it just keeps being A, right? What's the sequence of second differences going to be? Well, what do we have? We have A minus A, or A minus A continually. So it's just going to be 0, right? So we have A minus A minus A, A minus A, which is just the same thing as this particular sequence. Right, and to be fair, it just keeps going like that. All right, let's work example 2. We'll find the first, second, and third differences of these polynomials. This is a quadratic, right? This is the general equation for a quadratic function. So let's go ahead and do that. What is A plus B plus C minus C? It's A plus B. What is 4A plus 2B plus C minus A plus B plus C? Right? We're going the third row minus the second row. Well, it's going to be 3A plus B. And the next one, 5A plus B. You're right, we're subtracting. 9A minus 4A gives me 5A. 3B minus 2B gives me B. And C minus C is 0. So that's why there's not a C there anymore. And then if we look at our next one, our next first difference, if you will, we've got 7A plus B. And then 9A plus B for our sixth term. Let's find the second difference. What is 3A plus B minus A plus B? That's what we're being asked for. What is 3A plus B minus A plus B? Right? Well, what is that? That's just 2A, right? So this is actually 2A. All right. And what do we get when we subtract 5A plus B minus 3A plus B? Again, we get 2A. And believe it or not, we're going to have a pattern that's going to form there, right? So all of our second differences are going to be equal to 2A. And our third difference is? Well, that's easy. 0, right? Because 2A minus 2A is 0. And there we have it. We've done it. Let's look at example 3. We're going to find the second, third, and fourth differences. Wow. And so this is a cubic, right? This is the type of polynomial where we have our highest degree of x is 3, right? Which makes it cubic. So we've been given our first difference, so let's look at our second difference. So if we subtract A plus B plus C from 7A plus 3B plus C, we end up with 6A plus 2B. And then our second difference here will be 12A plus 2B. We'll have 18A plus 2B here. And 24A plus 2B for our last second difference. Third difference is, what is 12A plus 2B minus 6A plus 2b. Well, all we have left is 6a. And also 18a plus 2b minus 12a plus 2b is going to leave you with 6a again. And wouldn't you believe it, a pattern begins to form. And now we have our third and fourth differences. Now this is where we really get to the meat and potatoes of this. We are given a relationship, right? Remember, what it means that this is a relationship is that this is an input and output relationship, right? So this is our in, and this guy right here is our out, right? In other words, we could write this same table like this, right? X, we input some x into a function, and it outputs f of x. So what this means is that there is some, well, we'll call it a function. It's probably a function. I'm jumping the gun by saying that. But we'll be able to model this with an equation, and we'll be able to figure out what that is by looking at first, second, and third differences. Okay, so let's just look at this thing in terms of numbers. And then actually going to take this one step further, and we're actually going to find the function that is represented by this relationship, right? So in other words, what function do you plug in 0 into, and it outputs 2? But it's also true of all of those different values, right? You plug in 1, you get 1. You plug in 2, it outputs 6, right? When x is 3, f of x is 23. When x is 4, f of x is 58. So we're going to take this thing all the way, because you guys are in pre-AP Algebra 2, and you're good now. All right, here we go. So let's find our second difference as well. This one is going to be 6, right? Because 5 minus -1 is 6. And then 17 minus 5 is going to give me 12. And then we'll keep going, doing that subtraction. And then for our third differences, we wind up with 6 and a 6. And yeah, that's right. A 6. Okay, let's use this information from this table in order to actually find the relationship. Now, what type of a relationship do we think it's going to be? Well, if we look at our previous examples, which relationship ended with 0 for a fourth difference, right? Well, that was a cubic, right? That was the cubic. It was when we last did, right? So if we took this out and we did a fourth difference, we would wind up with zeros here, right? And that strongly suggests that this thing is cubic, but let's find out exactly what it is. Here we go. This is not in your notes, so you're going to have to write this somewhere. I'm going below. I don't know if you have room in your module for it or not, but here we go. So we have x values of 0, 1, 2, 3, and 4. All right, if we assume that this thing is a cubic, then it has a general equation ax cubed plus bx squared plus cx plus d, right? That's what every single cubic looks like. Okay, so when x is 0, all we have left is d, right? You plug in 0 in this x cubed, you get 0, right? Plug in the 0 for x squared, b times 0 is 0. Plug in 0 for the x in this cx, c times 0 is 0. So all we have left is D when we substitute 0 in for x. Hey, how about 1? Well, that's going to look like A plus B plus C plus D. What happens when we plug in 2? We wind up with 8A. We're going to wind up with 8A plus 4B plus 2C plus D. When x is 3, we wind up with 27A plus 9B plus 3C plus D. And lastly, when x is 4, we wind up with the expression 64A plus 16B plus 4C plus D. All right, there we go. Let's look at our first difference. So first difference. In other words, what is A plus B plus C plus D minus D? Well, A plus B plus C, right? So A plus B plus C, there's our first difference. We're going to go through the same process. We're going to subtract A plus B plus C plus D from 8A plus 4B plus 2C plus D. What's that going to give us? 7A plus 3B plus C. Our next difference will be 19A plus 5B plus C. And our last first difference, that's kind of weird, but it is a thing. 37A plus 7B plus C. All right. Well, you're kind of like, why? Why are we doing this? Don't worry, I'm getting to the punchline real soon. Here we go. Let's find our second difference. All right, in other words, what is 7A plus 3B plus C minus A plus B plus C? And just remember, right, we're distributing a negative sign, right? When we do this, be sure that you are distributing, right? You're actually winding up with a negative A, a negative B, and a negative C. It's actually the same thing as adding, right? 7A plus 3B plus C plus negative A minus B minus C, which is going to be 6A plus 2B. When we subtract, again, we wind up with 12A plus 2B. And then subtracting again, we have 18A plus 2B again. Ooh, a pattern is emerging. It's beautiful. Love it. Let's look at our third difference. And this is where we really get it, right? We wind up with 6A and 6A here. Well, why in the world did I just do that? Well, it's because I actually have a numeric value here, right? These 6's representing my third difference. And I also have a variable value, right? An expression that represents our third difference. And what that's going to do is I can figure out what this A is, right? And that A, that is the same A as that A, okay? They're the same A. And that is great news. Because that's going to help me to determine what this equation is. So essentially, what I can say is, hey, if the third difference is 6 and the third difference is 6A, then those two quantities are equivalent, right? 6A is equal to 6, which means that A is 1. Well, that's awesome, because now if I know that A is 1, it's going to be pretty easy for me to solve for B. And I'm going to solve for B using this one, right? So 6A plus 2B well, what is that? If we look up here, it's 6, right? We're looking at this. These things correspond. This 6 and this 6A plus 2B, they're the same. They're equivalent. So I can write that, right? I can write that they're equivalent. Now that I know that A is 1, I'm going to substitute. So that becomes 6 plus 2B, right? When A is 1, 6 times 1 is 6, plus 2B equals 6. And then I'm able to solve. 2B equals 0, right? When I subtract 6 from both sides. And I wind up, when I divide both sides by 2, B is 0. All right. So all we need to know is what A, B, C, and D are, right? And then we'll know the equation. So next thing we need to do is we need to figure out what is C. Well, in order to find C, we can use this guy, right? We know what A is. We know what B is. We'll be able to solve for C. And let's figure out which one matches. In our first difference up here, we have a numeric value for that. And it is -1, right? So it's this -1. And we're going to plug that in here since they're equivalent, right? Since the first difference numerically is -1, and the first difference in terms of an algebraic expression is A plus B plus C, those two things are equivalent. I'm going to substitute. So A is 1, B is 0, we don't know C, but now we do, because when we solve this, we get that C is -2. And then the really, really, really easy part is, what is D? Well, D matches up with our first output, right? So this is our D, right? And right next to our first difference here, this guy, that's also D, yeah? So then when we go back here, we know that D is 2. So now that we know what A, B, C, and D are, we actually know the exact value of we know exactly what the polynomial expression is that creates this relationship right here, this XY relationship. All we got to do is plug right back into this. We're going to plug A, B, C, and D back in here. Let's do it. Here we go. So we said that A was 1, right? So our function, it is a function, f of x is going to be, well, if A is 1, then we wind up with just x cubed, right? If B is 0, then our x squared term is gone, right? And what I'm doing is I'm plugging that into this. Ax cubed plus bx squared plus cx plus d, right? We're plugging those into there. So b is 0, so then that means that my x squared term goes away. C we determined is -2, so we'll have minus 2x, and d is 2. So there we go. There we have it. Okay, well, now that we've done that, You guys are ready to do some work on your own. We're not going to really mess with the last one. Just going to go ahead and let you know what your homework is. Okay, so your homework is on page S5, not 5, and it is going to be 3, 4, 5, and 6. In other words, 3 through 6. But where are we going to do that? We're going to do that in class tomorrow. Because remember, write down any questions that you have about this. I would love to answer them. And I'll see you tomorrow. Bye, guys.